A scatter plot is just a graph of data made up of points. And it's a plot of a lot of points that are scattered all over the place. So you could take, I don't know, get data from a lot of different information and plot the points, and when you're done plotting it, it could look something like this. Now, I think everyone would say, if they saw something like this, that this data seems to be going up. And we could even sketch in a line to try and fit to this. And we would say that this line is going up. And you know, because you've been paying attention, that a line that's going up or rising has a positive slope. Well, in the same way, this scatter plot is said to have a positive correlation. Right? Because in general, the data is going up, would be a way to see it. Right? That as one value increases, so does the other. They're changing in the same way. Now you could have another scatter plot of data, and you could generally see that as we move further to the right, this data is trending down, and maybe a line of best fit might fit in something like that. And you know that those lines that are falling from left to right have a negative slope, and in the same way we would say that this scatter plot has a negative correlation. And that is that as one value increases, the other is decreasing. Right? They're changing in different ways. And then you could take data, and when you plot all those points, it's really hard to tell what's going on. Right? It's just kind of all over. There's no sense of what's happening. And so this would be a case where, as far as we can tell based on this data, there's no correlation, there's no relationship between the two variables, as best we can tell. And so that's the difference between the types of correlation, and it really ties into slope. If the information is trending up, you have a positive correlation. If it's trending down, you have a negative correlation. And if you can't really tell, it's just no correlation. Now the second thing that we need to talk about, real briefly, is how to estimate what's called the correlation coefficient. This is just a silly estimate of a number. And basically the correlation coefficients will range from -1 all the way up to +1. And right in the middle is 0. Now everything from 0 to -1 is dealing with the stuff that has a negative correlation. And everything from 0 to +1 is all the things that have a positive correlation. And if there's no correlation, you have the value of 0. Now something is more positive means the values are close together, or tight. And things that are close to no correlation tend to be more scattered. So let me give you some extreme examples, and hopefully you can see that this is fairly subjective, what's happening here. So let's say we had a scatter plot, and we plot the data, it looks something like this. This is clearly a positive correlation, and the data is trending up, and it's pretty tight together. So someone might say that this has a correlation coefficient of +1. And somebody else might say, I think it's +0.8. But clearly that's tight together. You can have another set of data that looks something like this. Also trending up in general, but kind of scattered. Right? So the second group, because the data is kind of spread out, has a positive correlation, but it's not very positive. So someone might say it's 0.2. Somebody else might say 0.1. Right? The more clustered together all the points are, the closer to 1 or -1 the correlation coefficient would be. The more spread out that the scatter plot is, the closer to 0 the correlation coefficient would be. And it is kind of a subjective point, at least up to this point in time. Hope that helps with your reading.